Hello students, in this video we have two questions from assignment 6.6. In previous one we had 26 and 27th question of assignment 6.6 reciprocity theorem mainly we saw. Now in this video we have AC generator. We will see principle, construction and working of AC generator. What is generator? Generator is a device which produces electrical energy, and you have two types of generator, AC and DC. Okay, so we will see difference between AC and DC generator. Dynamo is the same thing. The difference between generator and electric motor, that also we'll see in this video. Though topic is just about AC generator, but the other topics are very much related and relevant. So we will briefly check DC generator and AC motor. Now we know that whenever we have any coil, placed near magnet, and if you move magnet, the flux linked with the coil changes, and hence according to Faraday's law we have EMF induced. And how much is the induced EMF? We know that it is d phi by dt with negative sign. Negative sign is the consequence of Lenz's law. What if I have a coil placed in magnetic field in such a way that it can rotate? Suppose this is the condition, and what if I rotate this coil? So right now the magnetic field lines are going from north to south, and if I consider area vector to be in same direction, I can say that the flux length phi is NBA, isn't it? Actually NBA cos theta. For now, angle between B and A is 0. So cos theta is not relevant, but just to remind us, I mentioned it. And now if I differentiate both sides, I will have d phi by dt is equal to NBA d by dt of cos theta. See, we are rotating coil. So number of turns of the coil will not change. B is external magnetic field won't change. Area of the coil we are not changing. Okay, so these three terms are constant. And what is the differentiation of cos theta? It is sine theta. So we have d phi by dt is equal to NBA sine theta d theta by dt. Okay. Uh, just a small point, math students should be knowing that if you differentiate sine theta with respect to theta, the differentiation is cos theta. Okay, so simply cos theta you can write. But if you are to differentiate d by d theta of sine of k theta, then the differentiation would be actually here you have d theta by d theta, but we know it is going to be 1, so it is simply cos theta. But if you have something with theta, then it becomes cos theta d k theta by dt, and now sorry d theta, and then the answer is k cos theta. In 11th standard you must have done it in the topic of simple harmonic motion. This is just a reminder. One thing I forgot here is differentiation of cos theta is minus sine theta, so I should mention minus sine here. Now we have d theta by dt as minus NBA sine theta d theta by dt. But what if I take angular velocity, speed of rotation, that is angular velocity is theta by t. In that case, theta is omega t, and then d theta by dt will be omega. So then this equation can be written as d phi by dt is equal to minus NBA omega sine of omega t. And we know that from Faraday's law dphi by dt is minus epsilon, and hence it is epsilon is equal to NBA omega sine omega t. This much EMF will be induced when you rotate coil between two magnetic poles. So if you consider that these are the magnetic poles, suppose the coil is placed between two magnetic poles, let it be north pole, and then you have coil placed here like this, then you have another magnetic pole, say south pole here, and now if you rotate this coil, suppose this is the axis of the coil, and then if you rotate the coil, what you are changing is flux field lines passing through this coil. Okay, and how much is the speed of rotation? It is denoted by omega, and this is the expression which gives us how much voltage will be produced. So in this case, if you look at the phi is NBA cos omega t, NBA cos theta, theta is replaced by omega t. So when you plot graph, suppose if I plot graph of phi versus t, the graph will be like this. But if I plot graph of epsilon, that graph will be like this. So look at the lines. Exactly when EMF is zero, blue line is indicating EMF, red is flux. So when EMF is zero, at that time flux is maximum, and when we see that flux is maximum, at that time EMF is zero. So that is the relation between flux and EMF, because one is function of cos, whereas the other one is function of sine, and that is how EMF is produced. So this is actually the maths part of AC generator. It is principle, electromagnetic induction is principle. Now, whatever EMF you have produced, how do we take it out of the generator? So for that, two rings are placed. Two rings are placed here. So rings remain at the same place, same point, and as and when the wire comes into contact, the carbon brush, these are the carbon brush, they are in contact with the red ring. Brush, this black one are also called brush. So if you have AC generator, you have complete ring. In case of DC generator, we have half ring. So suppose if it is DC generator, in that case, the same arrangement with slight difference. What is the difference? Difference is in the mechanism of taking out the EMF. In that case, you have two half rings. Okay, and two carbon brushes. So one will always remain positive, other will always remain negative. And if you see half rings, half slip rings, then it is DC generator. Whereas if you see two complete rings, then it is called AC generator. Okay, and what if I pass current through this coil? I'm not taking it out. Instead, I connect it with battery. Then the coil will rotate. So if you rotate the coil, you will get current. If you give it current, it will rotate. So that is what we do in electric motor. In electric motor, we give current and coil between two magnetic poles rotate. Whereas in case of generator, we rotate the coil, means we invest mechanical energy and in turn we get electrical energy. So that is the difference between electric motor and AC generator. And that is all we need to know about AC generator at this point. Mainly these two formula. Okay, that is all for now. Thank you.